Some of the most accurate, reliable, and powerful AI systems today don't rely on a single model. Instead, they rely on a team of models that think differently, argue with each other, and vote on the final answer. This is the world of ensemble methods, where diversity beats perfection, and where AI gets smarter by thinking together. If you had to trust your life with one prediction, weather, disease diagnosis, stock movements, would you rely on one model or a council of experts? Today, you'll discover why the best AI models today rarely work alone, how ensembles dramatically boost accuracy, and how you interact with ensemble-powered AI every single day without realizing it. What are ensemble methods? At its core, an ensemble method is simple. Combine multiple machine learning models, and the group often performs better than any individual member. Why? Because each model brings a different perspective. One might be great at spotting patterns. Another might be good at ignoring noise. Together, they reduce errors, smooth out extremes, and deliver more reliable predictions. Example: predicting house prices. Model A focuses on neighborhood. Model B focuses on house size. Model C focuses on recent sales trends. The ensemble mixes their strengths and suppresses their weaknesses. Everyday examples. Your email spam filter uses ensembles. Weather forecasting uses ensembles. Medical imaging, AI, uses ensembles to reduce false positives. The psychology behind ensembles. Human wisdom has used ensembles for centuries. Panels of judges, committees, multiple doctors reviewing a diagnosis. The idea of wisdom of the crowd. Ensemble learning is the mathematical version of this ancient technique, but with models instead of humans and statistics instead of arguments. 3 major types of ensemble methods. Bagging, bootstrap aggregating. Bagging is all about training multiple models on random samples of the data. Each model sees a slightly different world. Then we average or vote on their predictions. Simple technical detail. Bootstrap sampling means random sampling with replacement. Each model is trained independently. Reduces variance. Famous example, random forest. Random forest is one of the world's most used AI algorithms, powering everything from fraud detection to medical risk scoring. It trains dozens or hundreds of decision trees and averages them. The result? Powerful, stable, less overfitted predictions. Practical example, predicting credit card fraud. Each tree spots different fraud patterns. Ensemble catches more anomalies with fewer false alarms. Boosting. If bagging is about independence, boosting is about teamwork. Boosting trains models one after another, each model fixing the mistakes of the one before. Simple technical detail. First model makes errors. Second model focuses on correcting those errors. Third model fixes the remaining errors. Combined means strong classifier. Famous algorithms: AutoBoost, gradient boosting, XGBoost, LightGBM, CatBoost. These systems dominate Kaggle competitions, tabular datasets, and structured data tasks. Practical example, loan approval prediction. Each iteration focuses on misclassified cases like borderline applicants. The ensemble becomes extremely fine-tuned. Stacking. Stacking is like hiring a manager model. You train different types of models, say a neural network, a random forest, and a logistic regression. Then you feed all their predictions into a final model, the meta-learner, which decides the best combination. Practical example, movie recommendation system. Model A, collaborative filtering. Model B, text-based sentiment. Model C, genre patterns. Meta model blends all of them and comes up with more personalized recommendations. Why ensembles work so well. They work because they reduce variance, more stable predictions. They reduce bias, better fit for complex patterns. They reduce noise, less sensitivity to random errors. They combine strengths, like a diverse team. In almost every ML competition, the final winning solution is an ensemble. Real-world use cases. Healthcare. Finding tumors in medical scans, reducing false positives in cancer detection. Finance. Fraud detection, portfolio risk modeling. Weather and climate, storm prediction models, flood risk analysis. Tech giants, recommendation systems, ads ranking, search engines, spam filtering, all powered by ensembles. The future of AI won't be about a single perfect model, but about intelligent swarms of models thinking together. Ensemble methods show us a powerful truth. Accuracy comes not from perfection, but from collaboration. See you in the next one.